Today, dear viewers, my name is Villanueva, and my presentation is about a study by Danvir K. Ali and Radwan K. Alastroche entitled Geophysical Self-Potential Investigation to Detect Buried Water Supply Pipe Location in Kirkuk City, Northern Iraq. To start with the purpose of the study, which is to demonstrate the effectiveness of the self-potential geophysical method in accurately locating a buried and undocumented water supply pipe in a suburban area in Kirkuk City, Iraq. That said, the objectives of the study is to pinpoint the horizontal position, lateral location of the buried water pipe, estimate of the buried water pipe, and highlight the potential of the self-potential method as a valuable tool for utility detection in urban environments, particularly in areas whereas built records are unavailable or unreliable. Now let's proceed to the study area. Sakayin na nilang suburban area located approximately 5 kilometers north of Kirkuk City, Northern Iraq. The approximate coordinates of the area has a latitude of 25 degrees 56 minutes and 56 seconds north to 35 degrees 56 minutes 58 seconds north, and a longitude of 44 degrees 36 minutes to 23 seconds east to 44 degrees 36 minutes 25 seconds east. You can see this is the study site. This is the Sekanyan suburban area. And this is the satellite image of Kirkuk City, northern Iraq taken from Google Maps. Let's proceed to the materials and methods. The study employed the self-potential geophysical method as the primary tool used then used two non-polarizing copper electrodes connected to a high impedance voltmeter. As for the data acquisition, the grade measurements as follows. SP readings were taken at 20 grid points around the suspected pipeline location when water was not flowing, and at 23 grid points when water was flowing inside the pipe, and then the spacing between these grid points was 2 meters. For the gradient surveillance, two surveillance using a gradient froglet configuration were conducted. One line was 120 meters long along the foothill with 10-meter electrode separation. The second line was 100 meters long, perpendicular to the first, and the two shorter gradient surveillance, each 28 meters long and 3.5 meters away from the suspected buried pipeline. And as you can see here in the figure 3, this is the self-potential survey showing the two electrode configurations in the study area. In the figure 4, you see the site plan showing the measured self-potential points and self-potential gradient survey line designed at the study area. With that, the collected self-potential data were then or will be processed and visualized using Surfer 8 software to generate observed contour maps, regional contour maps, residual contour maps. And then the second horizontal derivative technique was applied to the residual self-potential maps, and curve anomaly analysis was applied to the gradient survey line data. Now let's proceed to the results and discussion. The first is the interpretation of contour self-potential maps for non-streaming water condition. The first one is the observed self-potential maps. As you can see, this map displays a numerous semicircles of maxima and minima positive anomalies. And the SP positive values range from a minimum of 2 millivolts to a maximum of 52 millivolts. The contour interval is 2 millivolts. For the regional self-potential maps, the regional contour map was derived using a second-order method, which shows a broad elliptical isopotential contour lines with positive values ranging 14 millivolts to 50 millivolts. And then the contour interval here is also 2 millivolts. Now, for the residual self-potential maps, the residual map obtained by subtracting the regional data and observed data exhibits many semicircles of both positive and negative anomalies. The positive anomalies have values of 2 millivolts, 12 millivolts, 20 millivolts, while the negative anomalies have 26 millivolts and 12 millivolts. The contour interval of this map is 1 millivolts. Next, for the interpretation of contour maps, this time it is for the streaming water condition. First is the observed self-potential maps. The observed map was dominated by negative self-potential amplitudes, ranging significantly from negative 2 millivolts to 44 negative 44 millivolts. There is a unique positive self-potential anomaly of 6 millivolts represented in the circumference of the map. And then additionally, the negative semicircle anomalies of negative 42 and negative 30 millivolts are spreading along the center line of the map, further indicating that the pipe's location. The control interval for this one is 2 millivolts. For the regional self-potential maps, as you can see, the figure shows that the second order regional self-potential contour map in the streaming water environment composed of broad elliptical negative isopotential contour lines with predominantly negative value and only a small part of the map showing positive contour lines. The contour interval is 2 millivolts and the values range from approximately negative 30 to 32 millivolts to positive 4 millivolts. Next is the residual self-potential maps. This is derived by removing the regional effect and shows predominantly many positive anomalies, including two elliptical forms of 25 millivolts and 10 millivolts, and another semicircle of 30 millivolts. There are also negative anomalies present, which are negative 5 millivolts and negative 15 millivolts. Uh, and along the center line of the map, and other negative anomalies are negative 15 millivolts and negative 35 millivolts situated in the border of the map. The control interval of this one is 5 millivolts and the values range approximately from negative 35 millivolts to positive 30 millivolts. For the second for the second horizontal derivatives, self-potential contour map for non-streaming water condition, it shows that most of the anomalies are located along the center line that runs through zero coordinate of the map, and the control interval is 10 millivolts, and the color scale indicates range from approximately negative 90 millivolts to 100 millivolts. The concentration of SDA's anomalies along the center line suggests a strong spatial gradient change in the residual self-potential data at the indication of the verified. And now proceeding to the non-streaming water condition, where most of the anomalies are located along the center line that runs through zero coordinate of the map. The control interval for this one is 10 millivolts, and the other color scale indicates the ratio from approximately negative 90 millivolts to 100 100 millivolts. And the concentration of these SHD anomalies along the center line suggests a strong spatial gradients change in the residual potential data at the location of the verified. Now for the streaming water condition, the map also reveals both positive and negative anomalies. It was emphasized that the major anomalies are situated along the center of the line of the map. And the counter interval here is also 10 millivolts with a color scale ranging from approximately negative 50 millivolts to 120 millivolts. So similar to non-streaming condition, the SHD map under streaming water conditions effectively highlights the location of the fluid pipe as as it lies along the center line of the studied area. Proceeding to the gradient survey line curve for non-streaming water condition. The profile shows positive potential values ranging from 30 millivolts to 50 millivolts. The curve exhibits somewhat irregular pattern with a peak around of 8-meter mark and uh, and another rise towards the end of the line. Okay. This suggests that even at a distance of 3.5 meters, the buried pipe still influences the self-potential measurements even though with reduced intensity compared to directly above it. Now for the streaming water condition again, the it shows a low positive self-potential measurements ranging from 0.2 millivolts to 1.5 millivolts. The plot indicates that the strong negative streaming potential is more located above or very near the pipe. And noticeable peak around of 25-meter rank and a low of the 22-meter mark. For the depth determination, we have with analysis to determine the depth of the pipe. By analyzing the shape and width of the self-potential anomaly curve obtained directly over the buried pipe during water flow, the researchers estimated that the depth of the pipe is approximately 1.4 meters using the half maximum width technique. This provides a quantitative estimate of the pipe's vertical location beneath the surface, which is crucial information for any future evacuations for maintenance work. And lastly, for our results and discussion, let's sum up. The majority of the observed residual and notably the second horizontal derivative anomalies consistently aligned along the center line of the survey area. And then the reduction in self-potential signals amplitudes with increasing lateral distance from suspended part location or as observed in the gradient survey lines support it supports the principles of potential field theory. The application of the half-wave method to the SB anomaly curve uh, contained obtained under streaming water conditions yielded a depth estimation of 1.4 meters for the buried water supply pipe. The study demonstrates the practical utility of this potential for locating undocumented buried utilities in urban environments like Kirkuk City. And the findings of this research can encourage the further application of the self-potential method, particularly for our future researchers. And that's the end of the presentation. Thank you for listening.